What about the restrictions? Same exact restrictions. Okay. All right. We good?
So how come well, I mean, I understand the U, but how come the restriction on B is the same as the first one?
Again, it goes back to the idea of if you were to look at it from here, what's happening in the XY plane, sorry, XZ plane is exactly what was happening with this one in the XZ plane.
It just happens to vary, okay.
Right? Imagine this. Imagine I draw this circle right here. Okay? That has a certain radius to it, right? You don't know, you can't tell by looking at it straight this way, you can't tell if this point and this point, you can't tell if those are the same distance from you. All right? Right? It's only the y coordinate would tell you that. So if I twist this back to where it was, right? And now let me draw that circle on there for you. It would have really looked more like this. That circle would have looked more like that, right? Now you can see one of those was closer to you than the other one. But the only thing that made that happen was this. Okay? So everything else follows the same exact formula, which is actually nice that that works that way. We good? Any other questions? Okay, what about S2? So what about S2?
It's a cylinder, but you're cutting it between two planes.
Yeah, it's a cylinder between two planes. So how do I draw a cylinder with that fixed radius? Right, because the radius of this is always 1. So again, if we turn it and we look at it straight through, whenever it does draw something, it draws a circle of radius 1, right? It has to be lying on a circle of radius 1. So the radius is no longer varying. Agreed?
Right.
Okay, so I'm going to put S3 here, or S2 here. So what are you suggesting? Cosine U. The Z being sine U. This is the hardest part right here. This is the hardest part.
Can you do V and set the 0 to the equation?
Exactly, perfect. That's the way we do it. We don't try and control our y coordinate in here. We want to control our y coordinate in the inequality restriction. Now here's why. Let's say this is going to draw me a circle, right? So imagine drawing the back circle like this. I kind of missed it there. What I'm going to do is I'm going to draw that back circle, and let's just say I'm drawing this point right here. That's somewhere on that circle, right? What I want is after I've drawn that point, I want my y coordinate to be able to vary back and forth between there and there. And if I pick another point over here, I want it to go here to here. Now remember, this is the front edge, right? It's really hard to see this. I think I messed that up, but that's the edge, right? So as I pick points along that circle, I pick the point, I fix the point, which would be, I plug in one of these u's, right? Any u between 0 and 2 pi, plug that u in, I've got a point on that circle. Then I want my y coordinate to go back and forth. So I'm going to let it just be v. And that v has to be stuck between what two y values? 0 is the back, and the front y value is this plane right here. Yes? So I'm going to let v be stuck between 0 and, again, this is the trickier part, z minus x plus 2. but we have to use these, right? So what's z? Sine u minus x, which is cosine u, plus 2. Got it? Can anyone tell me what would have happened if you would have instead put this right here? What it would have drawn? Basically, take v out of the problem, because that's what you would be doing, right? Take v away and just put that right there. What would it have drawn? Not quite. Which curve? Which curve is what I'm saying? Which of those curves would it be? It would be that, it looks like an ellipse, right? It would be this curve right here. See, because what you're doing is you're drawing a circle, but you're making your y-coordinate be out here on that plane, instead of letting it vary between 0 and the plane, which is the way we had it, which is the correct way. Understand that difference? Okay, so forget this. Don't want to do that. Don't want to do that. Do we have all the surfaces? Yep. Okay, we move on. Our goal here today is to try to get to 13.7. We'll see if we can. We haven't even started 13.6. I mean, this is just the introduction to it. All right, so what about this? Find the vector functions which yield the two surfaces shown here. So we have a bottom cap and then this little cover, right? So what do you want to start with? The circle on the bottom, that disk. Okay, what about that disk? Okay, so why don't we call this one S2? The one on the bottom there, we'll call it S1. S1 will be the vector function. What for sure? What for sure here? 0, 0. Okay, because it's on the ground. All right. And then the other part, it's a disk, which is a bunch of different circles with different radii. So v cosine u, v sine u. Are y'all catching on to this? Y'all getting this? What's your restriction on u? 0 to pi. Good. Restriction on v, 0 to 1. Now you can tell it's 0 to 1, can't you? But in the event that you were not able to tell, you could also find where this surface here intersects the xy plane, which would be setting this equal to 0, which would be a unit circle, right? So it would be 0 to 1. Okay? Any questions there? All right, what about S2? What's the main difference between S2 and S1? The z's not fixed anymore, right? Everything else is the same? I mean, other than the z? Right, if I look at that from the top, I can't tell the difference between those two, right? It's just the z that's coming out at me is the part that's different. So this should stay the same. But my z needs to be what? One minus this squared minus, sorry, minus this squared minus this squared minus v squared cosine squared. We're going to wind up doing Pythagorean, right? So factor out of negative v squared. The cosine squared plus sine squared will become 1. So this is really just 1 minus v squared. Yes.
Do you have to have the V though? Because if you're just going to draw the circle on the bottom,
Where? On which one?
on the surface 2,
Uh-huh.
for the X and Y coordinates,
Uh-huh.
do you have to have the V? Because if you just draw the circles, isn't it going to eventually draw all the circles to the top?
They won't be varying in radius,
Oh, that's right.
right? You want to circle. See, and this is the thing when you let V be 1, right? Sorry, let's let V be 0. When V is 0, where are we? 0, 0, 1. We're up here, right? Let's let V be 1, which is a radius of 1. We'll be at 1, right? 1, and then over here we'll be at 0, right? But this will be cosine u, sine u, 0, which is a circle, unit circle, z coordinate 0, which draws me the bottom like this, right? Then if I let v be a half, I'm going to get a smaller radius, and then this is actually going to be 1 minus a fourth, 3/4. So I'll be up here drawing that circle. Does that make sense? So you've got to have that v to vary the radius as you move up and down. We good? Okay. I think there's one more, right? Okay. So I told you the back side of this, y is 0. This right here, z equals 1 minus x squared. This right here, x plus z equals 2. And then, of course, the bottom of this, z equals 0, which means it's flat on the ground. I didn't do this one. Okay. All right, so where do you want to start? Let's do the bottom. Okay, let's label these. I'll just go clockwise. S1, S2, S3, S4. So for S1, this is R1 of UV. This is just a what? That bottom there? The bottom piece? Just a rectangle, right? It's just a rectangle? That's as clean as you're ever going to get. What can you tell me about the z coordinate? It's 0, okay. And then how about I just call the u coordinate u and the y coordinate, sorry, the x coordinate u and the y coordinate v. And then just go between two constants, right? U's between what? -1 and 1. Do y'all see that? That's my x values are between -1 and 1. My y values should be, so v should be 0 to 2. That's pretty clean, right? All right. What do you think is the next easiest? That S2, right? All right, so let's talk about S2. I'm going to draw S2 in the xz plane. It's that whole surface, right? That's what it is? Is that shape following, what function is this following right here? The parabola what? Z equals 1 minus x squared. It's coming from this thing, right? Anything that you can tell me straight away from this that's going to be nice? The y coordinate is 0, right? That's fixed. Now you have two variables that you have control over here, right? Let's switch our x to be the u. So I'm going to let my x vary, right? So I'm going to let my u vary between where and where? -1 and 1. What about my z coordinate? What am I going to put here? What's that? Z and let's use V, but yes. We're going to switch our X to U. We're going to switch our Z to V. And I'm going to call this V, and then let V be between, where? 0 and the curve, right? It'll draw me everything in between. So between 0 and 1 minus x squared, but for us, u squared. Understand that? Again, let me ask you one time again. If I put 1 minus u squared here, then you wouldn't have a v, and what would that have drawn? Just the curve, right? All right, I'm good with that. What do you want to do next? Let's take a vote. S3? S4? I'm for S4. The reason why I'm for S4 is only because it's almost exactly the same as S2, right? The only difference is, again, if we looked at it from down here, we wouldn't see a difference between S2 and S4, would we? The only difference would be the y coordinates coming out at us. It's changing. So the y is somehow going to be variable when we try and do S4. So S4 will be u. This will be v still. But what about the y coordinate? It's fixed, right? The y coordinate is fixed. So the way you can think about it is if we're going to use the same restrictions here, that's going to draw this, right? So I pick some u value. It's going to spit out some v value, which is really the z. But I don't want to be flat. Where do I want to be? So like I'm right here on that backside right now. I want it to come out and actually be that point instead, right? Not everything in between, just that point. So I need to move that y coordinate out to this plane. What's this plane equation? Wait a minute, is that right? Hold on a second. Did I write that down right? Ooh. That needs to have what in there? A y. Hold on a second. We need, do y'all see, hold on, let me look at my code here. Where did I draw that plane? Which one is it? That's supposed to say y plus z. My apologies. Y plus z. Do y'all see where I ran? Like I was sitting there going, oh shit. Do y'all understand why I was saying oh shit? Okay, because this plane equation right here, please change. That plane equation, I need to be able to solve it for the variable that I'm trying to get some control over, right? So this right here, we're trying to control the y. If I solve for y is equal to 2 minus z, right? Do y'all see that? So if you're going to live on this plane, you've got to have the equation 2 minus z to live there. And I know the z coordinate, don't I? The z coordinate is my v coordinate. So this should be 2 minus v. And then same restrictions as we had here. Is that okay? We're not done, but is that all right with you?
Yeah.
All right. For those of you who again like the code, I know no one. I keep on saying for those of you who like the code, no one has ever told me, yeah, I really like the code. This is basically what I'm doing here. Parametric plot 3D is a function that's built into this system. So I'm calling on the function parametric. This is a parametric equation, right? These are parametric equations. So I need to give it the x